Hey Geometry, today we're going to take a look at section 6.3, getting into some other tests for parallelograms. So we know that kind of by definition, if a quadrilateral has a pair of opposite sides are parallel, each pair of opposite sides are parallel, then it is a parallelogram. That's kind of what we call it. And so we can show that we know it's a parallelogram. But there's some other things we can do to prove that things are parallelograms. This is kind of similar to like our shortcut rules for like showing triangles are congruent or something like that. This is not about congruence, about what it is, but like side, 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 and so on. Those are short. These are kind of shortcuts for showing it. So if we can show that both pairs of opposite sides are congruent of a quadrilateral are congruent, if we have opposite sides are congruent, then we know we're dealing with a parallelogram. And again, there's kind of we could go through proving this, kind of glossing over this stuff, but we could slice this thing up into a couple of triangles to do our proof. If both pairs of opposite angles are congruent, then we have a parallelogram. And these are all kind of features of the things I've already mentioned, but they could kind of reverse it. If the diagonals of a quadrilateral bisect each other, and they both have to bisect each other, not just one bisecting the other, that's something else, but if they both bisect each other, then we have a parallelogram. And then this is kind of the weirdest one, I guess. If one pair of opposite sides of a quadrilateral is both congruent, I'm just going to do the little congruent, and parallel. I'm going to do the little shortcut signs for that. So if they're both congruent and parallel, we know it's a parallelogram. And there's, again, we could kind of go through the proof to show why that is, but suffice it to say, that's enough. So if any of these are true, then we can show that the quadrilateral is a parallelogram. So determine whether the quadrilateral is a parallelogram and justify your answer. Here I've got opposite angles and opposite sides, but notice that wasn't any of our conditions. I could have all four opposite sides, both pairs. I could do both pairs of opposite angles, but this one I can't be sure. I know these angles are the same. I don't know that these angles are the same. I don't have enough, and then I know that these sides are parallel, but I don't know that are congruent, but I don't know that they're, first of all, I don't know that they're parallel. They kind of look parallel, so that's the trick here. This looks like a parallelogram, but remember, we can't just go based on looks of like, this looks the same length as that, and this looks the same measure as that. Yes, it does, but that's not enough. So, no, we don't know for sure. Can't be determined with given information. It's possible it could be, but we don't have enough proof. Can't be determined. So maybe no is the wrong answer. Maybe just can't be determined. Determine whether the quadrilateral is a parallelogram. So like really, I'll just say this. Yeah, can't be determined. We're not sure. We can't deny that it possibly is, but we don't have enough information here. This one, I've got these consecutive sides are supplementary, so we can actually use a converse of the alternate, the same side interior rule, where these must be then parallel. So those are both same side interior and they're supplementary. So we can figure out that those angles, those lines are parallel. And then once we've established that, we've met our fourth criteria here, where both opposite sides are congruent because they're both 14, right? So they're congruent and they're parallel. So yes, we can determine based on this information that this is a parallelogram. So yes, opposite sides are congruent, parallel, I guess wrote that, and congruent, parallel and congruent. Hopefully that makes sense. The symbols there, parallel and congruent. All right, and then in C, we've got opposite sides congruent, and we got both sets of opposite sides congruent. So we don't have anything parallel here, but we have enough. So that meets our first condition here. So both sets of opposite sides are congruent. All right, so getting into some examples with this. A diagram shows the side view of a tackle box. I don't know if you guys ever seen one of these where these trays kind of fold up and stack out. At the left in the diagram, PQ is congruent to RS, so PQ is congruent to RS. So these two joints are equidistant from each other, and PR is congruent to RS. So the distance between these joints is are congruent to each other. Explain why the upper and middle trays remain parallel no matter what height the trays are raised and lowered. And so since opposite sides are congruent, for like both sets of opposite sides, so maybe we'll make that clear, both sets of opposite sides are congruent. So this is a parallelogram. PQ SR is a parallelogram. I'm just going to draw the symbol, parallelogram. And so then opposite sides are parallel. So PQ will always be parallel to RS. So, I'll do the therefore symbol. I don't know if I'm showing you this, guys. The 3 dots. I'm getting all kinds of shorthand here. Therefore, PQ, segment PQ, is going to always be parallel to RS. And that's the therefore symbol. You can write therefore if you want, or so, which is effectively the same thing. All right, next example. FK, this segment is 3x minus 1. All right, 3x minus 1. That's kind of tiny, sorry. KG is 4y plus 3. KG is 4y plus 3. And JK is 6y minus 2. And KH is 2x plus 3. Get all that in there. Find x and y so that the quadrilateral is a parallelogram. So I've got these diagonals. I know the diagonals of a parallelogram bisect each other. So I need to make this half equal to that half and this half equal to that half. And so basically we're just kind of finding the x and the y that make this true. So I know that the 3x minus y has got to equal the 2x plus 3. I'll solve that. I also got to make sure that the 6y minus 2 equals the 4y plus 3. So subtract some x's, minus 2x, bring this 1 over at the same time so I can cancel, and get x is 4. X is 4, we'll do it for the x's, over to the y's, minus 4y, get rid of this 2. So that's gone, and we're left with 2y is 5, and y is 5/2, or 2.5. All right. Your turn, so you can pause and try and do this. Find x and y so that each quadrilateral is a parallelogram. And I guess we just got the one here that you can try. So you can pause and try it out. All right, so setting this up, we know opposite angles are going to be congruent, so we need to make sure those opposite angles are congruent. So I know that 7x, what am I doing? 7x is going to be equal to 56. Make sure I have that as a 56. And so then we can divide both sides by 7 and get that x is 8. So that deals with the x, and then we know these sides have got to be congruent to each other. So I know that 4y plus 4 has got to be equal to 5y minus 26. And so I would go this way, subtract the 4y minus 4y, and we need to go ahead and get rid of this 26 plus 26. Gets rid of that, and so we've got 9y is 30, and so y is, what did I do wrong? Not 9y. Good thing to look up sometimes. Minus 4y. So that should just be y. Y equals 30. And there's your solution. That'll make that equal. So a little quick summary. To prove that a quadrilateral is a parallelogram, you can show that both pairs of opposite sides are parallel. That's a parallelogram, that's the definition. But, and then they list some specific theorem numbers, you don't need to know those. But we could show that the opposite sides are congruent, both pairs of opposite sides. We could show both pairs of opposite angles are congruent, that diagonals bisect each other, or that one pair of opposite sides are both parallel and congruent, and that will be enough.